This video will introduce how to train and use an object detection model. This model can be used to identify the position of objects in an image and classify the objects into different categories. The questions of where and what will be resolved. For the gears and saw blades shown, an object detection model can locate their approximate positions and mark them with different labels. This enables the positioning, classification and counting of the workpieces. We will take the rotor as an example. An object detection model will be trained for rotor positioning and counting. Here is the model training workflow. Add a new project, select the object detection module, import images, label images, train a model, validate the model, and finally export the model. When labeling images, pre-labeling methods are preferred to reduce the cost of manual labeling. To this end, only a small amount of data is manually labeled, and then a model is trained for pre-labeling. Now, open Mech-DLK. Click New Project. Name the project, and specify the path to save the project. According to the guidance, add a module. In this case, select the object detection module. Then add label classes. In the current scenario, there is only one type of workpiece, making it sufficient to create only one label. Next, import the image data. Navigate to the Import/Export button, click it and select Import Image. Import some of the data into the project. Then, select an ROI. Click the ROI tool. Adjust the frame to avoid interferences from the background, but leave some margins. Ensure that the ROI can cover the target object in the image. Upon adjustment, check that the rotors are consistently within the ROI for all images. Otherwise, readjust the ROI. Now, we can start labeling. Select Rectangle tool. Draw the bounding rectangles of the rotors. Once you have labeled the current data, train a model for pre-labeling and validate it. After this, import the remaining data for training. Click Pre-trained Labeling to complete the labeling. Check the pre-labeled data image by image to avoid omission. At this point, we have completed the labeling of the rotor. Here we need to split the dataset so that the ratio of training set to validation set is 8:2. Under Training, click Parameter Settings, then Training Parameters. Adjust the maximum number of training objects according to the actual situation. This represents the upper limit of the number of workpieces that can be recognized. Click Train, confirm retraining and start the object detection model training. Enter Training Center to view the progress of model training. Or click Show Chart to view the accuracy and loss value. After the training is completed, click Validate to validate the model with the current data. Check the validation results to confirm that there are no errors. At this point, we have finished training the object detection model for the rotor. Finally, click Export. Select a directory to save the trained model, which will be exported automatically. The model can be used in Mech-Vision or Mech-DLK SDK. Finally, a variety of example projects built into Mech-DLK are at your disposal. See also the documentation for more instructions.